Hello, friends. My name is Ishab Hundal, and I'm the one who have offered this project about discounted cash flow and the payback period method in the Future Factory projects. So I have received a few emails from students that they need to know some more minute details about the project and what is expected, and should they contact the companies, or should it be run like a standalone project, or should you be in affiliation with the corporate, with some real company? As a matter of fact, this project is not really complicated. You can do this project in many ways. It's a real life example which I want to share with you, that how this project can be run. A few days ago, I went to a showroom, and that showroom was selling some energy saving devices. And when I asked this person who was at this help desk, he informed me that this you can say this energy saving device, or you can call it some kind of inverter or something else, and many names depending upon how you view it. And he mentioned that this project can cost me about 1,800 euro, 1,001, no, 1,800 euros. So I wrote in euros, and this value is here. And then I asked the person that who are the main users of this device. And he mentioned that normally it's the commercial entities who use it, and especially the hotels are the one who use it because their energy bill can be very high, and they want to bring it down, and this inverter can be very useful. And on further query, this person showed me some project description, the product description on his monitor, that what are the main characteristics of this product, why I'm saying project, the product, which is the energy saving inverter. And he said that the estimated life of this product inverter is 6 years. It can go beyond easily 6 years, but 6 years are minimum, up to which this product would be showing best of its characteristics, and it will be very energy efficient. I said, okay, all right. Then on my further query, this person mentioned me, and in fact, he showed me some catalog as well, that this can save as much as for the first year, second year, third year, fourth year, fifth year, and sixth year. And he gave me very confidently for the first 3 years that it can save the energy about 400 euros per year, And then he said that maybe at the end of fourth year, this may not be so efficient. The graph a little bit goes down till we can actually consider that this is of no use beyond sixth year. And I wrote these numbers, which are of course in euros, and these are the money saved, which you can save on annual basis by installing this inverter. And I wrote here cash inflow. Of course, this inverter will not give you any money, but it's saving your money. And if you go by the basic tenets of business studies, the money which is saved is money which is earned. So it's like a money coming in. When you don't spend it, it means you save it. It stays in your wallet. So I found out that 400, 400, 350, 325, 325, 300, these are the money saved during the lifetime of this inverter. But then I realized in this column where I write discounted cash flow, I realized that this first benefit, I'm talking about now, the money would go out from my wallet if I want to buy it right now, 1,800 euros. But the first benefit I would get at the end of first year, at the end of second year, at the end of third year, so on, at the end of sixth year. There is a distance between lip and the cup. Things can happen. There is a risk. It could be possible that this 400 euros, which is the current value of 400 euros, its value may go down at the end of first year, It can go even down at the end of second year. It can go even down at the end of third year. We know that there is a concept called present value of money, which means that money now is more important than the same amount of money you get in the future. So if somebody gives you offer that would you like to have 500 euros now or 500 euros after 1 year, all else being equal, you would say 500 euros now. Because the 500 euros which you get not now, but at the end of year, it could be possible that you may not get it in the first place. There can be many risks involved. So therefore, I thought that this guy is saying 400 euros. Maybe he's considering 400 euros now, even though this benefit would come after 1 year. So I applied the discounted cash flow method. What is a discounted cash flow method? It's based on the saying that a bird in hand is worth two in the bushes, which means that what you have, what you own, is more important what you are visualizing. And this is a visualization of saving energy cost after 1 year. So I want to find what is the present value of this 400 euro, which I would get after 1 year now. So basically, I want to find out this 400 euros I would save after 1 year, but how much is the present value of this 400 euros now, considering that there can be some risk. Now, the concept of risk is very complicated, but for this project, I thought that maybe inflation can be a risk. If there is an inflation, the value of money goes down. If the interest rate goes up, the value of money goes down. So I thought that maybe I should take the risk factor as an inflation rate and interest rate. And when I realized that maybe the inflation rate is about 3%, 2.5 to 3%, the future forecast I saw in Bloomberg, and then I also saw that the interest rate could be about 1% or so. So when I added it, it makes about 4%. This is my estimate, and I write it here as well, that these are the estimated or the forecasted value of the discount rate. Discount rate is the rate which considers the risk factor when you are estimating the future cash flows. Either the money is coming in or you're saving the money. Okay, so in either case, whenever you want to find the true value of money in the future, it will never be riskless. And this discount rate incorporates risks. There can be other risks also. There can be, in some countries, if this example is not in case of Finland, and if this example is in case of some country where the political stability is not so much, there can be a fear of army coup, or there can be some undemocratic powers can come in the framework. Then I would also add maybe political risk. How much, what percentage is expectation? So that I can also add here. But I think because I was taking this example in Finland in a showroom, local showroom based in Jyväskylä. So I thought that inflation and the interest rate risk are the only two visible, prominent, and significant risk. And when I added them, it became 4%. So I assume that the 4% is the risk for the next 6 years, which the cash flows would be affected by. And then I find out, I remembered the promise or the commitment or the claim, which this showroom, this marketing person said that it will save 400 euros at the end of year 1. But I was interested, what is the value of that 400, which I would earn after 1 year now? And then I used this formula. And I found out that the 400 euros, which I would save after 1 year, is worth 384.62 euros now. 384 euros, 62 cents. I think I should also write here in euros so that there is no confusion. Sorry. And then, and remember, if there's no risk, just imagine we live in a country, in a situation, in a very idealistic world where there's no rate of discount, there's no risk factor, and the risk factor is 0. Then believe me, if you put the values in the formula, this 400 would be 400, this 400 would be 400, 350 would be 350. But the fact is that it's wrong to assume that there is no risk. So we have to go with some likelihood of risk. You can never take one single objective value of risk. You have to use some estimation or some forecast. But you can't just cook up those numbers, have a forecast in reliable sources like Bloomberg or Yahoo Finance or Wall Street Journal, or even on some Ule's business page. You can get some ideas, or even you can get some estimates of inflation or the interest rate on Suomi Pankki's website as well, very precisely in the context of Finland. Anyways, this is after 1 year, and then I have one more 400 euros, which I'm expected to save as per the claim of this gentleman who work in the store. And when I find this value, I put to the power of 2, because then the money which I save after 2 years, I have the risk of first year, and I also have the risk of second year. That is why the risk is multiplied twice. And to incorporate it, I put to the power of 2. Here, the power is only 1. I didn't mention it, doesn't matter, because this risk is only for 1 year. But the money which I save at the end of second year, the risk is for 2 years. And the money which I save after third year, at the end of third year, yeah? So the risk is for 3 years. And the money which I save after fourth year, the risk is for 4 years. So I'm not only taking the risk exposure, but I'm also keeping into consideration how many years I have to tolerate the risk to get some saving in my energy bill. So much so that the last saving, as per my estimate, which is 300 euros, I go with to the power of 6, because that is, I have to wait for 6 years. So I have a more risk exposure, lengthier time span. And then I add up all of this, and I find out that all the sum total of the future cash inflows / saving, if I have to find the present value right now, before I make this investment, in time 0, means time now, if I have to add up all the savings for the next 6 years during the lifespan of this machine, this device, it comes out to be 1,847 euros and 62 cents. In other words, my benefit is this much and my cost is this much. Why can't I add these values and compare with this? Because here, the periodicity, they are not arising in the same period. But this value is estimated to be arising now. The present value of all the future cash savings, all the savings, savings in terms of energy bill, the cost, expenses. So my sum total of, so the present value of all the sum total of the future savings is this much. And my present cost, if I buy this device, is 1,800. And I find that my sum total of benefits are more than my cost, 47.62. It's worth an investment. It's worth an investment if I only see this device. But imagine I have another product which is almost giving the same, functions, same features, and this value is more, So when I subtract the present value of sum total of all the future savings minus present value of my expenses, which is right now, if this value is not 47.62, but 67, 68, 200, 300, then I will not invest my money in this project. Then I will buy that device, which have a larger net savings. Or if I compare this machine with some another machine, and by doing the same process, the value is below 47.62, then I will not take that alternative. Then I will go for this one. So this is what you can do. To get the data, you can go to a showroom and find out the same questions which I mentioned in the beginning, that, hey, you meet somebody and say, well, what is this device? Check in the internet that what type of devices are good for energy saving, or even water saving, or even some other, sustainability thing. And then check out that, talk to the person at the those who are the sales assistant, and ask all this information, some estimations, and then you can calculate this saving. Or you can meet somebody who have some newly constructed house, and they have installed all these energy saving devices, or water saving devices, or even food saving devices. Or you meet somebody who works in the hotel, and you can ask the same things to that person. So this is all about the discounted cash flow. But then we also have one more method, the payback period. The payback period method, basically, in a nutshell, is that how fast, how quickly you can recover your cost. And that is called break-even point. How fast, because if you spend money on this device, it will be 1,800 euros. How quickly you can recover 1,800 euros if you are saving this, and this money in terms of annual savings. And for this purpose, the first part is same. And here you can see that I'm adding accumulated discounted cash flows. And here I can also write in euros so that there is no ambiguity. And what I do is, the first value is same, but this value is basically the sum of first and second year. Then this value is sum of second and third year, sum of third and fourth year, and so on and so forth. And I find out that at the end of sixth year, I get 1847.62, and this seems quite similar. But here is a catch. The catch is that when I see that I have recovered, remember I invested 1,800 if I want to invest. The present value of my recovery as per this data at the end of fourth year is 1610. Then I would be interested in calculating how much more money I needed to make it 1,800. And I find out that if I get 189.48, at the end of sixth year, that would be covering my cost, because 1610.52, if I add 189.48, that would be making equal to my break-even point, which is 1,800. And then I realize that actually I'm getting 237 at the end of sixth year. So I actually get 237 euros and 9 cents at the end of sixth year, which is the present value now. But I only need to cover the cost 189.48 euros. And then I find out that what percentage is what I require divided by what I get. And I find out that I need to get 189.48, which is G14, but what I get is 237.09, which is F13. And when I press it, it comes out to be 0.8. It means that first, second, third, fourth, full 5 years, plus I need 80% of the sixth year to cover the cost. 80% of the sixth year. And then I find out that it actually 80% of a full year, so 80% of 12 months is 9.6. 80% of 12, 9.6. So I can round it off to full 10. So it means that I would be able to recover the cost. I would be able to recover the cost of my investment in 5 years and 10 months. So I would get the benefit for full 6 years, but I would be able to recover the investment in 5 years and 10 months. As a rule of thumb, shorter the payback period, if the cost is same, the benefits are comparable, then we prefer that investment whose payback period is shorter. Theoretically, if you can find some project which has the same cost, but maybe different cash inflows, and you find out that you can recover the same cost, 1,800, in not in 5 years and 10 months, but maybe in 4 years. It means your money will be stuck only for 4 years, not for 5 years. So then prefer that project, prefer that investment. But if you find an alternative project whose cost is, if not same, but similar, but the savings are different, and you find out that you need 5 years and 11 months to recover the cost, then I think this project is better. So these are the two basic, very hand-on projects whose data you can obtain from, basically you can have a chit chat with the sales assistant of these electronic devices, or you can talk to the person who have already installed them, whether at home or in some commercial building. So this is something which I wanted to explain to you in a nutshell, but just in case you have any issues and you want more clarifications, please feel free to contact me, and hope you like this video and you get some ideas from it. And keep in touch, and thank you very much for your patience. Have a nice day.